Hello, everyone, and welcome to today's lecture. In today's class, we are going to begin our study of semiconductor diodes. Before we understand how a diode works, we first need to understand some basic concepts about semiconductors. By the end of this lecture, you should be able to understand what a semiconductor is, the difference between conductors, insulators, and semiconductors, what intrinsic and extrinsic semiconductors are, what doping means, what p-type and n-type semiconductors are, what majority and minority charge carriers are, how a p-n junction is formed, what the depletion region is, what barrier potential means, what a semiconductor diode is, what forward bias and reverse bias are. And finally, we will introduce the VI characteristics of a diode. So let's start from the very beginning. Before talking about diodes, we need to understand materials. From the point of view of electrical conductivity, materials can broadly be divided into three categories. The first is conductors, the second is insulators, and the third is semiconductors. Let's understand each one. A conductor is a material that allows electric current to flow through it relatively easily. Examples include copper, aluminum, silver, and gold. Copper is commonly used in electrical wires because it has good electrical conductivity. Why does a conductor conduct electricity? The simple answer is that it has a large number of charge carriers that can move relatively freely through the material. When an electric potential difference is applied, these charge carriers can move, producing electric current. Now let's look at the opposite. An insulator does not allow electric current to flow easily. Examples include rubber, glass, plastic, and dry wood. Insulators have very few free charge carriers available for conducting current under normal conditions. That is why plastic and rubber are often used around electrical wires. They help prevent unwanted current flow and protect us from electrical hazards. Now we come to the third category. A semiconductor is a material whose electrical conductivity lies between that of a conductor and an insulator. The most commonly used semiconductor materials are silicon and germanium. Silicon is particularly important because it is widely used in modern electronic devices. Almost every modern electronic system contains semiconductor devices. Your smartphone, computer, television, calculator, and many other electronic devices all depend on semiconductor technology. But what makes semiconductors special? The important thing is that we can control their electrical properties. By adding small amounts of specific impurities, we can change the number and type of charge carriers in a semiconductor. This process is called doping, and doping is extremely important for creating devices such as diodes and transistors,